Hey guys, welcome back to chemistry. I know it's been a minute since you guys were in here, but last class what we talked about was a thing called molar mass. And if you remember, that was down here on like this chart kind of thing right here. That was what the molar mass, where we figured out how much mass there is in 1 mole of a specific compound or a specific substance. We're going to be doing that again today, but we're also going to utilize that with some dimensional analysis to figure out how many grams are in certain numbers of moles or how many moles are in certain numbers of grams of substances. So we're going to be using it as a conversion factor. So this conversion factor is defined this way with the molar mass. It says the molar mass is simply the mass of 1 mole of a substance, which means it can be used as a conversion factor. So here in our conversion factor, we can write 1 mole of the substance is equal to the molar mass in grams of a substance. Okay, so a question where that might be used is like this one, number 1 here. How many grams are in 0.5 moles of aluminum oxide, which is Al2O3? So we have a conversion factor for that kind of written in here. Blank moles equals blank grams. And now you're going to have to actually figure out what that is. So to do that, you're going to need to fill out this little chart here for Al2O3, just like we were doing last class. So we're going to go back through that again. You start off by looking at all of the elements that are in your compound. Here in this compound, we have both aluminum and oxygen. So I'm going to write aluminum here for my element and also oxygen for my element. And then you're going to look at the number of atoms present here. So aluminum here is given with a 2. So that means there are 2 atoms of aluminum in every compound unit of aluminum oxide. And then similarly, O has a 3. So that means there are 3 oxygens in aluminum oxide as a compound. And then after that, we needed the average atomic mass, which you can find on the periodic table. Now I've got my little periodic table over here, so we can go look at those values for average atomic mass. For aluminum, it's telling me it's 26.982. So I'm going to write that down for aluminum, 26.982. And I also know oxygen is 15.999. That comes straight off the periodic table. Now, what we need to do, if you remember, is figure out the total for each element, aluminum and then oxygen. We do that by multiplying. If you got 2 atoms and each one has a mass of 26.982, we can multiply to get our actual mass. It's going to take me a second to pull up a calculator and do that. Normally, I have you guys calculate, but today I'm on my own. So we got 2 times 26.982 turns out as 53.964. And then oxygen, similarly, is 3 times 15.999, and that is 47.997. And then what we did with that last class is we added those up, took those totals, added them together, which is going to give us, give me a second, 101.961 grams. And that's what we learned how to do last class, is figure out how much mass is in 1 mole. But this guy right here that we came up with at the bottom, that is the conversion factor that you're going to use in your chart up here. We said 1 mole of Al2O3 is really 101 grams plus a little bit, 101.961 grams of Al2O3. So then we can use this conversion factor to answer the actual question that was asked. And the question that was asked is how many grams are in 0.5 moles of Al2O3? Now, I know it's been a while since we used the chart, so I'm going to go through the procedure one more time. First, we start with our given information, and our given information here is 0.5 moles of Al2O3. So that always goes in your first little box. 0.5 moles of Al2O3. That's what we're starting with here. And what we're trying to figure out is how many grams are in that amount. And we're going to use this conversion factor that we just wrote in order to do that. Now, if you remember from before our little snow break, whatever unit you have on top has to go on the bottom next. So we're going to take this part of it, the 1 mole Al2O3, and put it on the bottom. The reason for that is because we want moles and moles to cancel out. But when you do that, you have to take this other portion, the 101.961 grams, and that's going to go on top. 101.961 grams of Al2O3. So now we've gotten rid of the moles unit. We have the grams unit. And our last thing to do is the actual math. For the math, we're going to multiply all of our numbers that are on the top, divide by all the numbers that are on the bottom, which in this case is really just 1. So you can kind of ignore it. And that's going to give us our answer, which is 50.981 grams are in half a mole of Al2O3. Okay, so that's kind of the full process. Let's do one more to make sure you guys have got it. This one says how many moles of sulfur is 186.32 grams of sulfur. Now this one's a little bit different because it doesn't have a chart. And that's because this is using just a regular old plain Jane element. Sulfur is just a single element by itself. So we can take its molar mass directly off of the periodic table. My periodic table shows me that sulfur has a mass of 32.066 grams in 1 mole. That comes straight off the periodic table. 1 mole of sulfur is 32.066 grams of sulfur. And then similarly to above, we're going to take our starting number. Our starting number is 182.32 grams of sulfur. And we're going to place that in our top left corner of the box. 186.32 grams of sulfur is what we're starting with. And we're trying to get it to moles of sulfur. So if you look at what's on top here, on top we have grams, which means I'm going to have to take this grams portion of our conversion factor and put it up here. 32.066 grams of sulfur goes on bottom. That way grams of sulfur and grams of sulfur cancels out. And then on the top, we're going to put the other half of that, which is 1 mole of sulfur. So we've gotten rid of grams. Now we've got moles, which is what the question was asking for. And we just have to do our little bit of math. Our math here is multiplying on the top, 186.32 times 1, and then dividing on the bottom with 32.066. So it's 186.32 times 1 divided by 32.066. If you do that correctly, I believe you should get 5.812 moles of sulfur is what you end up with. Okay, so to recap, guys, you're going to do molar mass like we learned last week, and then you're going to plug that into the conversion chart that we also learned last week. So we're kind of combining those two skills to switch around from grams to moles or moles to grams. Sorry I couldn't be there with you guys today. I'm at a robotics meet. I'll see you next week, though. So if you've got any questions about this, you'll be able to ask them at this time. There is a practice that you should have picked up when you came in for this. And there's also a teacher made in Google Classroom that you need to complete. And that's going to tell you whether or not your answers are correct. All right. See you guys next week. Hope you're having a good day and have a good weekend.